this real world data. Extermination, the number of bugs caught in traps X days after the start of an extermination program is shown. Write a polynomial function to model the data. Okay, so you are going to right now enter this data into your stat, edit, list 1 and list 2. So your X should always be your list 1 and your Y should always be your list 2. I will enter it also with you. If you did it with Miss Davis last year, you found a line of best fit. But sometimes sometimes data can actually fit a polynomial, can fit a quadratic, it can fit a cubic function. So we are going to actually have to look at this polynomial. If you don't remember how to plot it, let me go over the steps real quick with you. Once you've entered your data, and I'll write this down here at the top if you don't remember, because you can put it on your note card or for a test or something. But you hit second y equals, and you turn on this screen that says stat plots. Sorry, it's a little blurry, but it says stat plots. You want your plot 1 to be on. Mine is actually already on, but I'm going to just show you. You hit enter, and right now it's on, and you want the type to be the first one, the dotted one. Now that your plot 1 is on, and again, you can check to see it's highlighted right up here. Plot 1 is highlighted. You have to tell the calculator to graph that plot. Particularly, you have to hit zoom 9. Zoom 9 is your zoom stat. If something is not correct right now, I can fix it for you. But here's what you should get. What does that look like to you, polynomial-wise? What degree does that look like to you? 4. Why is it 4?
It looks like an M.
Like an M. Usually 4 M's and W's are degree 4. So just to kind of follow this pattern here, we have this M shape. I'm pretty sure then it's a degree 4. So I am going to quit and go back to my home screen. We are going to find the actual polynomial function, because that's what the sheet says to do. Go to stat, go over to calc, and this time you are not going to choose linreg. You're not finding a linear regression. You're not going to find a quadratic regression. We're going to go to quartic, which is number 7. Hit enter. It's going to take a moment. There it goes. Now, it gives you a long formula. It says ax squared plus bx cubed plus cx plus et cetera to e. These are all the coefficients in front of the polynomial degree terms. Let me just first talk about the first one. If you write down negative 4.9 x to the 4th, you're wrong. Why? Tell me why. Because what is this right here? What does e to the negative 4 mean? It means that you are a small decimal. That means you move the decimal over to it's actually doing scientific notation in your calculator. So the way you have to write this is y equals negative 0.000, and I'm going to round it to 5. And then write x to the 4th. Now your letter B doesn't have an E, so you can actually just round it. I would round to about 2 decimal places. So plus 0.03 x to the 3rd. C is negative 0.76 x squared. Then plus 6.92 x. And then your E, which is your number all by itself, plus 0.24. Quick question though, do you get out an R value like I do? Do you have an R squared? It says R squared, not R, but R squared. Okay, if you don't, I have to show you how to turn that on because you're going to need that for your homework. If you remember, if you hit mode and go down to where it says stat diagnostics, mine is on. If you have the old calculators, you actually have to go to the catalog and turn the diagnostics on. So I can do that with you in a minute. But check to see if you have mode and if you can scroll down and turn on your stat diagnostics. That'll give you that R squared value. Okay? Yes, Brian?
Have you fixed dimension mismatch?
I'll fix that for you. I have to do that separately. Okay, let me explain something real quick about that. Yes.
So when it's in scientific notation,
Yes.
can we do like the number before it's only 3 zeros and not 4?
No, good point. No, because the 4 means you're moving the decimal place to 4 spots, which means there's 3 zeros in front because you've moved it. You went 1, 2, 3, 4. That's why. Okay. All right, let me talk about this real quick. We've done R, which is the correlation coefficient. The correlation coefficient had to be close to 1 or -1. If you square 1 for me, what do you get? 1. If you square -1, what do you get? So R squared, the closer it is to 1, +1, the better your data model is. So this is actually, this model right here, -0.005x to the 4th, et cetera, is actually not a bad model. It's 0.82. That's not that bad. I mean, I like it to be 0.9, but 0.82 ain't that bad. Okay? All right, I want you to do what we just did. Practice this. Do number 2. And for those who have calculator problems, like Brian, bring it up to me. So kind of goes down and up. So a lot of people might be thinking that this is quartic. So if you do stat calc quart reg, that's an R value of 0.96. That's not bad, right? That's really actually a really good model. Did anybody do the cubic one?
Yep.
Is the cubic higher?
It's the same.
It's the same. Ah, okay. So which model do we use when they're the same? Is it really exactly the same or is one actually slightly stronger?
Yeah.
This one's higher? Oh, well, that's funny because that's what my book is saying it's not. I would pick the one that actually is higher. Then I would have picked this one. I would have gone against this and gone with quartic. Yeah.
It's the same answer.
Well, like I said, your answer is going to be, if you're R squared, it really wouldn't matter in this case for this one, if you chose cubic or if you chose quartic, because the R values are really so entirely close. But you would just have y equals -0.0008 x to the 4th plus 0.15 x to the 3rd plus, what do we have, -2.9 x squared plus 17.8x minus 26.2 with an R value of 0.9588. What was the cubics? It was
9587.
9587. Yeah. See, no, I would definitely go with this one. This one's stronger.
You don't want-
This one's definitely stronger then.
would you do them?
The equation is completely different.
And yes, it's going to be. But remember, these are based off of real world. Not everything in life, and which I'm about to show you, is always going to be predictable from a model. There's always some, what do we call, outliers, okay? And that's what could happen from that, just this graph right here, going like this, like that could have been, that little dot right there could have been the outlier when really it should have been doing this the whole time. So that's why we don't, it's based off of a real life data. Yes, Brian?
I don't have an R, like I have everything else.
I'll fix that in 1 minute, Brian. Let me go on to my next problem.
I can just not one in this section.
Yeah. Okay, so one more. We're going to do this number 3 together. The table shows the town's population over an 8-year period where year 1 refers to 2001. So one more time again, put this into your list. And this is a much easier, there we go. All right, so looks like an M again. Would you agree? All right, so let's draw the scatter plot. So, and again, on tonight's homework, you just have to give a little sketch. You don't really have to be completely accurate. I should make you be completely accurate, but your calculator is doing it for you, okay? So there's our scatter plot. So again, I'm gonna go with the fact that I believe it to be a degree 4, and I'm gonna find that polynomial function based off of the degree 4. So go to stat, calc, I'm gonna go down to quartic, and I'm gonna write my polynomial function out. So I have y equals -5.3x to the 4th plus 105.6x to the 3rd 753.6. Is this what you're getting, I hope? Okay. And if you notice, my R is fantastic. My R squared, again, is 0.969. That is a really good model for this. Part C says, use this model to estimate the population of the town in year 2012. What do I have to do with 2012? What do I do with that? Plug it in where? And I don't plug in 2012. What do I actually plug in? 12. Now, is there a better way for me to do this rather than plugging it in? Anybody think?
Use for statistics equation.
Excellent. Do you all remember that from last year or not? Do you want me to go over how to do that? Because the other class remembered, but still a little iffy. Your calculator has this equation in it. So let's let the calculator plug it in, right? So the way to do that, if you don't remember, is go to your y equals right now. Just go to y equals, and I'll write this down on the side. Y equals. Then go to vars right here next to the word clear. Go down to 5, which is statistics. So y equals vars 5. Then you have to arrow over to where it says EQ. And the first thing that comes up says reg equation. It's the regression equation that the calculator just found. So y equals vars 5, EQ, and then do reg equation. It should paste it right in. Did it paste it right in for you? And then you can hit graph and it'll actually draw that line. It's similar to doing a line of best fit. It's drawing that line. As you can see, it's kind of off it a little bit, but still not really that bad. It's still pretty close, okay? Now, I'm gonna go to the table, and I'm gonna start my table at 12. Why am I starting at 12? Because I'm trying to find the population in year 12. And I'm gonna go to my table, and I'm gonna get negative 7,013. So in the year 2012, this town has no people in it. Actually, I take that back, has less than no people. It has, what, zombies walking around it?
Yeah.
I don't know. How do you have less than no people? Okay, so here's where mathematics and I don't get along. Because I love math because it's beautiful and it's always right. But in this case, this equation is not right. Even though it's a really good, strong R value, you cannot use it. So what do we have to do then? We go to 1 degree model less, which is terrible because you're like, wait, what? This is a great model. It doesn't work for it's not true to our real life statistic. So we're gonna go and we're gonna go to stat calc, we're gonna go to cubic reg. Let the calculator do the work, hit enter. Okay. You don't have to write this down. We're going to paste it into our y equals. So go to y equals, hit clear, and then do this whole thing again. Vars 5 EQ reg equation. Vars 5 EQ reg equation. Hit graph, and again, pretty good. But, again, it's missing this guy over here. I hate this model, but when I go to the table and I actually look at year 12, I have people. I have 6,069. Is it roughly that? Okay. So that is what happens. When you're dealing with real life, this is what happens. Your models aren't always that accurate. Again, you're only basing it off of 1, 2, 3, 4, 5, 8 years. That's it. The more data you have, though, the better your model will be. All right, one more question. Approximate the year in which the population reaches 10,712. So what do we do there? What am I looking at now? Look at what? The Y. I got a 10,713. What year was that?
2016.
2015, 2016. Okay. This is what your homework's going to be like tonight. You have to decide sometimes that the model you're using is actually not the best one. It's just terrible. But definitely go with your R values on most of the cases. Brian, I'll fix yours.